Hey guys, this is a short, very short video about slope. And slope, if you can learn one thing really well in Algebra 2, it's slope. So let's see. Slope essentially is just something that measures change. So how things are changing. And in particular, this is the rate of change. And we'll be looking at slope in a number of different ways, but in sort of like the most traditional form, what we can do is think about this in terms of points on a line. So if I have some point here, and let's give it coordinates here. And remember our coordinates are x comma y. So this means my x value is 1 and my y value is 1. And maybe I have some other point that is 3 comma 2. Now there are a number of different ways that I can get from this point to the next point. There's one path. Some other path might look something like this. But if we think about if we go a constant change, in other words, a straight line. So if we start here, did that work? And have this line going right through these points. Close enough. So once we have a straight line, what that means is that for every change in x, for every constant change in x, I'm going to have the same change in y back. So I'm going to move over some in the x, and I go the same amount up in the y. So in other words, the change, or the slope, is constant. So let's think about that. Now, while there are a number of different conventions for measuring change, the one that we're going to adopt for our slope is to think about the change in y given a change in x. And we do that because our y value is our dependent variable and our x is independent. So, in other words, y is changing because x changes. So if we go back to that original case of 1 comma 1 and 3 comma 2, and we think about the line that contains those points, well, we could construct a little triangle here, and we see that the change in y, well, I went from 1 to 2, so my change in y equals a distance of 1, and my change in x, I went over a distance of 2. So x is 2. So change in y over change in x is 1/2. So this is my slope. And this says for every change of 1 unit in the x direction, it changes 1/2 units in the y. Now this has some really, really, really profound implications. So let's just look at one more example here. Let's say, again, I'm at the point 1, 1. And I have a slope of 1/2. So that means that, if I go over 1 in the x direction, I'm going to go up 1/2 in the y direction. So I've got a slope of 1/2. Well, if I just think about any point on this line, so if I just choose some point on this line, x comma y, what I can do is say, well, the slope is the change in y. Well, my change in y is just y minus 1, because I started at 1 and I finished at y. So change in y would equal y minus 1. And the change in x, well, I started at x equals 1 and I finished at x, so my change in x would be x minus 1. And I know that this equals 1/2. And again, that's just because we were saying, like suppose there is a line that goes through the point 1, 1 and has a slope of 1/2. So, if those conditions are met, then every single point on that line must satisfy this equation. In other words, that any collection of points on the line, there are an infinite number of points. For any point I choose, for any xy point I choose, y minus 1 over x minus 1 must be 1/2. Let's do one more step, because this is pretty cool. So then we got y minus 1 over x minus 1 equals 1/2. Well, with a little bit of multiplication, what can we get to? So if I multiply this by x minus 1, I'm multiplying by the denominator. When I do that, the x minus 1's on the left-hand side cross off, and what I'm left with is a really nice equation. And we could simplify this more, but I think I'll stop for right now. And remember where these values came from. This was our y value of the point that I knew. This was the x value. And this was my slope. And this, because we have a point and a slope, this is called the point-slope form. Not florm, but form.